In this video, we're going to go ahead and talk about arrays. So here in this example, what we have done is we've declared an array that can hold up to 5 elements, and that's what the allocated size is referring to. So a max of 5. We know that with C, the index that we start off everything from is 0. So 0, 1, 2, 3, 4. And so we use the name of the array, which in this case is double array, in conjunction with the index to refer to each one of these slots. We know that bounds checking is something that is going to have to be done by the programmer. So if we go outside the bounds of the array, then we may be overwriting into the memory spot of another variable. Now, this is certainly one visual that we could use to go and represent an array, but I'd like to go and introduce another visual that we'll come to see as being more helpful when we talk about pointers. So in this visual, what we've done is instead of actually having these boxes laid out in this way, we have kind of like a tree visual in which this is the root of the tree, and here are the branches, and the 0, 1, 2, 3, 4 refer to the various elements. And if we're wanting to go and assign a value, we'll just go ahead and sort of put it on the leaf. So if double array of 1, for example, is a 90.5, we just go ahead and put 90.5 right there. And once again, we'll come to see why this will be helpful later on in the future. So this is just a very simple example of a single-dimensional array. Let's go ahead and move on to our next example. Here we're going to go ahead and take a look at a two-dimensional array. Here we have a 2 by 3. So there's the visual. This is row 0. This is row 1. And so 0, 0 gets us access to that. 0, 1, 0, 2, so on and so forth. And once again, there's no bounds checking, so we have to be careful not to go outside the bounds. Now, just as we were using the tree visual to represent a single-dimensional array, we're going to go ahead and do the exact same thing to go and represent a two-dimensional array as well. So what we have here is row 0, and this is row 1. And these are all the elements of row 0. These are all the elements of row 1. So if we want to go and store something, let's say in 0, 2, 0, 2, that's where the information would go, which would be equivalent to that location right there. And so you notice that when we have a 2 by 3 two-dimensional array, we can hold a total of 1, 2, 3, 4, 5, 6, or rather just multiply 2 times 3, which gives us the 6. Now, we could have easily gone ahead and declared just a single-dimensional array with 6 elements. So why is it that we haven't done that? Well, with these arrays, when we add these additional dimensions, all that we're gaining is just a different way of organizing our data. In a sense, you can imagine that each one of these is kind of like a bookmark. And so this bookmark is allowing us to go ahead and go over to this set of information. This bookmark allows us to go ahead and jump on over to another set of information. So it's a convenient way of organizing our data. Certainly we could have just a 6-element single-dimensional array, but then we would actually have to go through each one by one. Whereas with this, we've realized that our data, for example, is grouped in pairs of 3, for example. So this is what that visual is showing us. So let me just give you another example of how this is done. So here we have a 3 by 4 array, and so we have 0, 1, 2, 3, 1, 2 rows, so a total of 3 rows, and of course all of these columns, and so 1, 3 would get us access there. If we wanted to go ahead and use the tree visual, once again, 3 times 4 is a total of 12 elements, so you'll find that we have a total of 12 elements. If we want to go and store something, let's say, in position 1, 3, and here 1, 3 would be right there, and here 1, 3 would be right there, and so we could actually just go ahead and put the information right there. Now, once again, we could go ahead and declare just a single-dimensional array of 12 elements, but what this allows us to do is to go ahead and just group these 12 elements into groups of 4. So there's a bookmark pointing to the first set, another bookmark that is pointing to the second set, another one that is pointing to the third set. So it's just a way of organizing the information. Moving on further with this example, this is a good example in terms of just knowing how the information is stored. If we have a 2 by 3 array and we go ahead and populate it with some information, so the additional brackets inside, or the braces, they actually tell us that this is for the first set, That's for the second row. So 5 and 6 are going to go into the first row, and then the 1 is going to go into the second row, and then all the other boxes are going to be filled with 0. So we have now populated this array with a bunch of data items. Now, equivalently, if we want to go ahead and use the tree visual, you notice that we have the 5 and the 6 right there, and then we have the 1 right there, and then we have a bunch of zeros. Now, let us say for a moment that we go ahead and skip the inner braces, and we go ahead and initialize this two-dimensional array in this way, 5, 6, 1. So we have the 5, 6, 1, and you notice that now at this point, we're going to go ahead and put the 5 there, the 6 there. The 1 no longer goes into the second row, but rather it just continues on. And so this is basically telling us that we're going to go ahead and just populate the information in a consecutive sequence. Because all of these, when you declare an array, we're basically declaring these consecutive, this area of memory, and all of these areas are consecutive memory locations. And we'll find out in just a bit that these indexes are used to actually go and do some pointer arithmetic that will get us to the various parts of the array. Now, let's just modify this for a moment. Let's just say if we were to go ahead and do something like this, okay, 5, 6, 1, 2. So 5, 6, 1, and then where does the 2 go? If we were to go ahead and use a visual like this, some folks would actually make the mistake of thinking, that the 2 would be outside the bounds, but that is not the case, because the memory is sequential with regards to this array that's been allocated. The 5 would be there, the 6 would be there, the 1 would be there, and the 2 would actually go in the next spot, which would be right here. So we actually just move on to the next area in memory. So that's the tree visual. Now let's just very briefly talk about passing arrays. So when we're passing arrays, let's go down again, just made it a little bigger. So let's say that we have a single dimensional array, so int a, and we pass the array, there it is, and then over here we go ahead and catch the array. So there's that. Of course, we know that this name is a formality. We can call this whatever we want. We use a single set of brackets with no number in there. The number is, of course, optional. And the reason for this is because, as we'll come to see when we look at the pointer syntax, is because C doesn't care about bounds checking. That's why we don't really care about putting a number in here. So what we do is we just, in essence, what we're doing when we pass this A, we're passing the beginning location of where the array starts. And having that beginning location, we can actually figure out where the other elements are. Here is a two-dimensional array, and so if we want to go ahead and pass a two-dimensional array, there it is. We just use the name of the array by itself, B. And then on the receiving end, we have B, and then we have two sets of brackets because it's a two-dimensional array. And the first one, once again, we can just ignore with regards to the number, but the second one is needed. And the reason for that being, and we'll delve into this a little more, but with a two-dimensional array, if we come down here, we'll find that here C doesn't really care how many rows we have, but C does care how many elements we have for each row, because that is what is going to go ahead and determine how to go ahead and group this information together. And at this point, this sounds a little vague. When we talk about the actual pointer syntax and addresses, it'll begin to make more sense. So remember that when we're passing arrays, first and foremost, of course, we're passing it by reference, which means that whatever changes are being made inside of the function, that they will affect the original array. And when we're passing the array, just the name of the array by itself will do in the function call. And on the receiving end, well, what are we passing? Well, we're passing really the beginning address of the array, and this is how we catch it. And the bracket is there to actually tell us that we're dealing with a single dimensional array. In this case, with a two-dimensional array, we have the first one and the second one. This one right here becomes mandatory, but the first one is optional. And the same rule applies when you're dealing with a three-dimensional or four-dimensional array. When you're passing it, just use the name of the array by itself, and on the receiving end, you want to have as many brackets as the number of dimensions, and the first one is the only one that can be left blank. Now here's a little chart that I have created which takes you through the various options. So let's say that if you want to go ahead and send an entire array, so here we have this 3-element array, you pass in the 3-element array and then you catch it. Once again, on the receiving end, it's optional whether you actually put a number in there, and here are what the prototypes could actually look like. And with the prototype, as you well know, the name of the variable is optional. It's not really needed, which is why we have this as an option available to us. We can also go and just pass one of the elements in the array, as we have it right there, flunc A1. And in doing so, really what we're passing is just a plain int, and so on the receiving end, we just go ahead and catch an int. And once again, here's the prototype indicating that we don't really need to have the variable name in there. That's optional. Now, we could also go ahead and pass just a single element by reference. Now, it is important to keep in mind when you're passing the entire array, whatever changes are made inside the function are going to affect the original array. When you pass one of the elements, whatever changes you make to that one element will not be reflected back. This is a pass by copy. In this case, this is a pass by alias, and there was a previous video that you guys watched where we actually talked about pass by alias. Really what we're doing is we have an ampersand here, and we're passing in just a plain int, and so there it is, we're passing a plain int, but when we prefix the variable name with an ampersand, this is saying, you know, that don't create another memory spot for this function. You're basically using an alias to go ahead and refer to that same element inside of the function where the call is actually taking place. So whatever changes I make here will actually go ahead and affect ace of 1 here in this function. And once again, the name of the variable is not needed. This is for a two-dimensional array, the name of the variable, and then we catch it, the first set of brackets being optional. We could also go ahead and pass one of the elements in a two-dimensional array, and one of those elements is just a plain int, and so we catch an int. And of course, that same element that we're passing, that one single element, we can pass it by copy, or we could pass it by alias. And remember that this is really just a plain int, so there it is, it's an int, and when we prefix it by an ampersand, this means that we're not creating a brand new variable. Whatever changes are being made, they're going to influence the original element that we're looking at. And then here's another one where we actually go ahead and say we are looking to go ahead and really just pass the address of the second row, and this is the notation that we are using, and this will become more clear in a later video. And finally, this is how we pass a three-dimensional array. Once again, just the name of the variable by itself will do, and then in the function header, all the brackets are needed. There are 3 sets of brackets, and we need a number for all of them with the exception of the first one. That one is optional. And of course, in the prototype, once again, the name of the variable is optional. It's not really needed.